Hi, my name is Vikram Kumar, and my project is evaluating the effect of lung mass on the performance of CNN machine learning models in differentiating COVID-19 from pneumonia. So before we start this presentation, I'd like to talk a little bit about myself. So I'm from San Jose, California. I'm 14 years old and I'm currently in ninth grade. Some of the hobbies I like doing are playing basketball, running, and coding. So first off, why is this issue important? Why do we need to make a project about it? So, misdiagnosis between COVID-19 and pneumonia is a serious issue. Even though COVID-19 is not as prevalent as it was in 2020 and 2021, there are still hundreds of thousands of COVID-19 cases every month. And around 9% of COVID-19 cases were initially misdiagnosed with pneumonia, according to a study conducted by the European Journal of Medical Research. And COVID-19 requires a different treatment than pneumonia. If a patient does not receive the proper treatment for their disease will grow worse and in some cases even become fatal. So a research question for today is, what is the effect of lung mass on the performance of CNN machine learning models in differentiating COVID-19 from pneumonia? So let's discuss some key terminologies first. What is a CT scan? A CT scan is an imaging test that uses X-rays to create detailed images of the lung. As you can see in this first image, the patient goes through a machine like this, and it gets this X-ray, and these X-rays are what we use to train the machine learning model. Now, what is a CNN machine learning model? A CNN machine learning model stands for a convolutional neural network model, and is a type of image classification model uses different layers to capture details and make predictions. So these are some of the key features of a CNN machine learning model. Convolutional layers apply different filters to the images to capture details to make predictions. Pooling layers reduce the overall size of the image to make computations more efficient. And activation functions activate different neurons in the machine learning model to help the neural network learn complex patterns. And all these layers are fully connected to help capture details that will make the final predictions. Now, how are CNN machine learning models used in medical diagnosis? They're used to diagnose medical images without the possibility of human error. Human error is a big factor in misdiagnosis. Implementing machine learning can help reduce this issue. And these models are trained off data sets containing medical images like CT scans. And once they're trained, they can be used in medical facilities if they have sufficient performance. Now, what is the disadvantage of using a normal CNN machine learning model? A CNN machine learning model is not used to CT scans, and it'll factor in all the details of the image. And this could include the background, which is not what the model is supposed to be focusing on. And for a problem like this, if the model focuses on the background instead of the lung, it'll capture unnecessary details that'll make the model confused and lead to a drop in accuracy when encountering new images. Now, what is a lung mask? A lung mask crops out the background of the image and leaves only the lung. And this can help with the issue of the model focusing on the background images because when only the lung is left, it only focuses on the details of the lungs and it can capture the small details that can help make predictions between COVID-19 and pneumonia. Now, these are a number of images that I used. COVID-19, I used 3,616 images, and I used 1,345 images for pneumonia. But for this experiment, we need to have the exact same number of images. So I used a method called data augmentation to help increase the number of pneumonia images. Data augmentation is a method that applies different filters or other methods of changing the images to add more images, and essentially we can increase the data set and get the same number of images for pneumonia and COVID, which will help reduce bias between the two uh, sets. Now, this is a training, validation, and testing split. For training, we use 72% of the images to help the model learn how to make predictions, and validation is to prevent overfitting. Overfitting is when a machine learning model memorizes the images instead of actually learning how to predict it. So when it encounters new images, it's not going to accurately predict it. And testing is to get the final performance of both the models so we can accurately compare them. Now, this is the model accuracy over 10 epochs. An epoch is one complete pass through the training dataset. And over the 10 epochs, you can see the lung mass model had an overall higher accuracy than the base model. Now, we applied the testing batch and we got the final performance of both the models. The lung mass model had a 95.98% accuracy, and the base model had an 86.73% accuracy. And the loss for the lung mass model is 0.0842, and the base model has 0.353. Well, these are the different metrics that we use to calculate the final performance. For the loss, we want it to be as low as possible because this is the difference between the predictions and the actual results. So, in conclusion, the lung mass actually did increase the accuracy of the model and boosted the accuracy by more than 9%. And this is everything that I used. The data set for this experiment and the CT scans were gathered from Kaggle.com. I programmed and tested the models using Google Colab, and I used TensorFlow for the machine learning framework. Now, do we have any questions?
Thank you, Vikram, for that fantastic presentation. Let's see, do we have any questions yet in the Q&A? I actually have one while we wait for any audience questions. Can you share what your test design was? What I mean is, could you walk us through the steps you took to test your model's predictions?
Okay, so for testing the model, so the overall data set, I divided it into training, validation, and testing. So the testing is completely new images. So this is used to see how well it can predict new images. So once the models were trained off of the training images, it was fed the new images to see whether it would accurately predict it or not. And the accuracy was calculated based on how many images accurately predicted and how many images did not accurately predict.
Got it. And can you tell me the images that you used in your data set, when you said that it accurately predicted or it didn't, does that mean that the images also included analysis of whether it was COVID-19 or was it pneumonia?
So for the training images, it would say the machine learning model would know if it's COVID-19 or pneumonia like beforehand. But for the testing, it would not know. So it has to try to like find out, and then once it makes its prediction, it would compare to what it actually is. So if it's COVID-19 or pneumonia, and then based on that, it would calculate the accuracy.
Very cool. We just had a question come in from the audience. Is the goal of this to completely eliminate the human aspect of diagnosis, or is it more of a tool to help inform doctors of a possible diagnosis based on previous ones?
So this technology is used to assist doctors. So human error is like a big problem in like misdiagnosis. So machine learning models don't have this problem, but it's not used to completely like eliminate like the like human diagnosis. It's used to like as a tool to like assist doctors in like help them.
Awesome. Well, that was fascinating. Thank you so much, Vikram.